Hello all. Thank you for joining the live stream class on YouTube. Now I want to give an example on what we studied last, that is capacitive transducer. And now the calculation of under the capacitive transducer, we want to check the example now, after which I'm going to give you an assignment that you are going to submit. All right. So let's go to the example now and see how we can apply the formula. Now, remember, we discussed the capacitive transducer, and we learned that the capacitive transducer is made like two concentric cylinders. And then these two concentric cylinders, they are the ones that serve as capacitors. You know, the capacitors, they are the wall of the two cylinders form the capacitor, because they are parallel to each other, since the two of them are placed inside one another. So the walls are parallel to each other, and the distance between the two plates is uniform. All right. So right now we want to demonstrate, we want to revise that, and then actually demonstrate also the calculation under it. Now, if you check now, you see the capacitive transducer theory. The device is made of a concentric type of containers. The tank is formed in form of a concentric cylinder, so that the capacitance is developed between them when a high frequency electrical signal is passed through the probes. Now that is essentially the summary. Now when you see what you see on the screen now, you can see the sketch of the capacitive transducer. The outer tank is what you see here. See the outer tank. And then we have the inner tank. The inner tank is here. You can see it here. And the inner tank has openings through which the fluid or the liquid inside the tank can actually move inside the larger tank. Now we have the probe in the middle here, and the wall of the inner tank, inner cylinder, is actually forming a parallel plate with the middle probe, whereby a capacitance is developed between the two of them. And the calculation of the capacitance will help us to determine the height, H subscript L, of the liquid in the tank. And then H subscript V, is the height of the vapor on top of the liquid. Now, when you add the two heights together, H subscript V and H subscript L, then it gives us the H, which is the total height of the liquid. The total height of the tank. Now, since we have liquid and we have vapor, we are going to have two different permittivities. So we have permittivity of liquid, epsilon L, permittivity of vapor, epsilon V. Then we have the radius of the inner probe as R1, and the radius between the inner probe and the inner tank as R2. So with these parameters, we can use a formula to calculate the height of the liquid in the tank. Now, checking your screen now, you see the formula. We have the formula here. C equals 2 pi E naught. E naught is permittivity of free space, multiplied by EL HL plus EV HV, divided by log base E of R2 over R1. Now, the parameters here, they have been defined. The EL and HL, they are the permittivity of liquid and height of the liquid in the tank. EV and HV, they are the permittivity of vapor and the height of vapor in the tank. And then R2 and R1 are the two radii that are indicated in the in the sketch, as you have it here in the sketch. So having these parameters, one can calculate HL out of this formula if the capacitance is measured. Now having that capacitance measured, as we have in this formula, now from this formula we can make HL the subject of the relation, and then it can be calculated out. All right. Now we want to see the example that will help us to understand this equation and then apply it Now, when you check the screen now, you can see the example. The example states that in a capacitive method of level measurement, it is found that the capacitance between the electrodes is 0.0056 microfarad. And if the diameter of the inner and outer electrodes are 20 centimeter and 125 centimeter respectively, calculate the height of liquid, which is actually castor oil in the tank. The height of vapor is 600 centimeter. E naught, permittivity of free space, is 8.854 times 10⁻⁻12 farad per meter. EV is 1.3 and EL, castor oil, is 4.7. Now, solution. C equals 2 pi E naught EL HL plus EV HV divided by log to base E R2 over R1. Now, when we rearrange this formula, you can see that we can make HL the subject of the formula here by multiplying both sides first, or dividing both sides first by 2 pi E naught. If you divide both sides by 2 pi E naught, we now have C divided by 2 pi E naught on the left-hand side of the equation. Then you can multiply both sides. You can cross-multiply now. Rather, cross-multiply. When you cross-multiply, we have C divided by 2 pi E naught multiplied by log to base E R2 over R1. And that's what we have is in the first part of this bracket here. Now, when you have that, you can subtract EV minus EVHV from that relation. Then, at that instance, you are going to have ELHL on the other side of the equation, from which you can make HL the subject of the formula. So we have 1 over EL brackets C log base E R2 over R1 divided by 2 pi E naught minus EVHV. That is what we are going to have when we make HL the subject of the relation. Now, substituting all the parameters in the equation above, we have this. 1 divided by 4.7 brackets 0.00567 times 10⁻⁻6 divided by 2 pi times 8.854 times 10⁻⁻12 multiplied by logarithm to base E of 125 divided by 20 minus 1.3 times 0.6, closing the bracket. Whatever you calculate inside the bracket here, everything you get must be divided by the EL, that is 4.7. So if you determine all this on your calculator, you'll get 54.11 divided by 4.7. And when you do that, you come out with the answer, 39.52 meter. Now, take note that there are two parameters given in centimeter. Excuse me. Two parameters given in centimeter, that is 20 centimeter and 125 centimeter. The inner and outer electrodes. The diameter of inner and outer electrodes are 20 centimeter and 125 centimeter. Now, if you look at that, we look at the formula that we use the diameter straights rather than using the radius or even converting the value into meters. The reason being that we needed a ratio. So if you use diameter or radius directly, you are going to get the same answer because we needed a ratio between the two radii. And also, we didn't have to convert to meter. If you converted to meter, we are still going to get the same answer if you do not convert it. Here, we do not convert it. We use it directly, 125 over 20. Since it's a ratio and the unit is the same for the both of them, we are going to get the same answer. So take note. But the final answer that we obtain here is going to be in meters, not in centimeter, because all the parameters that remains, they are dimensioned based on SI units. So for that reason, we're going to have the final answer as in meters, not in centimeters. So that is the calculation there. So I expect anybody that goes through this to actually use calculator to confirm what we have on this, line of the calculation. Confirm that it equals to this, and then finally that it equals to this. That's the final answer. So you confirm that with your own calculator when you are reading this. Then after that, you will go to the assignment. The assignment question is here, just like what you have on the example, but with only changed values. Just exactly the same question. In a capacitive method of level measurements, it's found that the capacitance between the electrode is 0.0067 microfarad. If the diameter of the inner and outer electrodes are 15 centimeter and 120 centimeter respectively, calculate the height of liquid, that is castor oil in the tank, if the height of vapor is 60 centimeter. Then we have the parameters of the permittivity of free space, the permittivity of vapor, and permittivity of liquid, which is castor oil. The parameters are given here. They are constants, so we don't have to bother about that. So go ahead, solve this problem on a sheet of paper, write it out. After writing it out, you can scan with your phone, or you can snap it clearly and send it to me. So I expect you to submit either on Monday, before Monday, or on Monday to submit to me. So that is it. So I hope to see your solution. I know the answer to this problem. So when you submit your solution, it's going to be graded as part of the CA. So that is how it is. So thank you very much for taking time to go through the video and solve the problem. So that is how we stop on this example. Another time, we're going to have other examples also. All right.